All right, guys, we'll go ahead and get started here. Welcome to our webinar. I've been thinking about doing this for a while now with Phil Gutowski here from BoatRX. If you don't know me, my name is Erik Haaland. I'm with David Walters Yachts, and I've known Phil for a little while now. He's actually done some projects for us, namely with Jeff Kennedy on his Italia 1498, which was delivered earlier this year. Phil did an awesome job with a complete lithium-ion electrical upgrade and a thermodynamic VRV air conditioning system and alternators and that sort of stuff. It's something that it's been high on my mind in the past couple of years, that this technology is maturing, it's growing, it's starting to be installed by OEMs. And it's something that's now available from some key manufacturers. Even if it's not, Phil's company's been working with these boat builders to actually install these systems with agreements now and that kind of thing. So I'm going to go ahead and just introduce Phil here. He's from the Boston area, correct? Originally?
Lived in Boston for about 15 years, but I grew up in Buffalo, New York. I was a Great Lakes sailor.
Okay, there we go.
Yeah.
And Phil recently, in a year and a half ago, I guess, moved down to Annapolis, and you're
That's
living
right.
aboard on your Tiana with
That's right.
With your fiance, soon to be more than a fiance. That's what
right.
I guess. Word on the street. And
Israel. Yep.
yeah. How'd you, you've been in the business now for a little while. How'd you get started in this business? How'd you become BoatRX?
Well, Eric, thanks for having me, and hi everybody. How did I get started in BoatRX? It was really a roundabout way. The paths of life, often diverged in different ways, and but really the central theme of my life was boating, and boating always came back into my life in different ways. And the boat that I have now, that I live aboard, was really the core of my inspiration for BoatRX, because I started refitting that and applying, just getting curious about the different systems and really learning it like 10, 15 years ago. And that evolved into me working on, the boats of my neighbors and trying to make something of it. And we fast forward, we've been in business for about 8 years, and we've grown. We're a team of 5, still small and growing. But now applying kind of these forward ways of thinking and trying to do things a little bit differently in the industry.
Oh, fantastic. I mean, you guys are definitely on the cutting edge of what's going on out there. I'm seeing the systems you guys are being installed on a lot more boats, and you're working with some pretty influential people out there. I know you told me you were just up at Hinckley doing a project.
That's right.
A project for Italia Yachts, with Aquapar, with Aquila. You guys are really working on some cool things.
Mm-hmm.
What do you, with your boat right now? I've been watching on your Facebook page. You've been doing a lot of work in your own boat. What are you doing there?
Well, we've stopped calling it a refit and started calling it a restoration, because it's been a massive project, and the thing I'm most excited about is finally, after all these years of talking about this stuff and installing these amazing systems for our clients, I'm giving myself a dream power system. And with the support from some of our vendors, we're getting a really big lithium battery bank, 48-volt system, fast charging from the main engine alternator, whisper power variable speed generator, and thermodynamic VRV system. So we're going to take our battery powered air conditioning system, and I don't know if we'll go around the world, but my fiance Lisa and I are really excited to finish this restoration of the old boat and really put it back into use, because my core passion is sailing, and that's what brought me into, and so many others, into our industry. And so right now we're in the thick of the grind and working really hard and growing this business. And I also hope that in a year from now we'll be setting sail and doing some cruising.
Awesome. Well, I think that's everyone's dream, is going out there doing some cruising. And one of the big things that's really been in the market or on the top of people's heads is making it comfortable. And I think we saw that in the past couple of years. It kind of started off with communications, Starlink, came out there and the world transformed along with COVID. The marine industry morphed into something different, and now people are spending a lot more time on their boats than they used to. And I think you guys have the technology out there that has enabled that comfort to go further, going away from split unit air conditioning to more the VRV style and the lithium ion batteries and the charging capabilities and what's possible out there. So I know you've got a presentation for us, so I think I'm going to stop talking now, and I'll let I'll let you kick it off and tell us what you've got.
Yeah, no worries. Thanks for the intro. Yeah, we'll jump right in. I want to tell you a little bit about our business, what we do, and really just spend the next 25 minutes sharing kind of the way I think about energy on board boats of all different kinds. And first off, I think I just want to point out that, we're experiencing this big shift to electrification in boating, and you see it all around you. I mean, many of you that are on this call, you might already drive an electric car, or you might have solar panels on your roof or a backup battery in your basement. Electrification is hitting every motive industry market, and it's beginning to hit boating in a really big way. And, since boats are kind of like a vehicle and a house all in one, I don't think they're quite ready to go all electric, at least not for most cruising applications, right, with electric propulsion. But in the meantime, we have all this great opportunity right now to enhance the efficiency of our onboard comfort systems. And we got all these appliances and systems that are on the boat that use electrical power. But when we're talking about efficiency gains, it just really makes the most sense to start with the one that uses the most power, which is the air conditioning. And that's partly because a lot of us use our air conditioning all the time we're on board. So if the air conditioning uses so much power and we need it all the time, then where does this power come from? Well, if you've been in boating for a little while, you know that when you're plugged into shore power, that's how you run all the systems in your boat. And when you're off the dock, usually to have air conditioning, traditionally, you need to run a generator to have air conditioning. So the thing is about these generators is that when they're designed for the boat and sized for the boat, they're typically oversized. And they're oversized so that it can run all of the systems in the boat often at once, meaning that we need, if there's multiple air conditioners, if there's a water maker, galley appliances, and all that sort of thing, we need to be able to turn them all on and have the generator support those electrical loads. Now, I will also refer to electrical loads a lot in this talk, and the load just refers to the amount of power that's required in the moment to supply the appliances. So the thing about these onboard generators is that they're sized for the maximum electrical load, but they're not always operating under this maximum condition. I mean, what happens the rest of the time, like when people go to sleep? We're only using a small portion of the power that the generator is producing. I mean, imagine you go to bed and a lot of the times the air conditioning kind of cycles off. You're not using any of the other appliances. So if you take a look at the chart that's on the screen, you'll see the amount of fuel that's consumed for the amount of power that's generated. And you can see that the less power we generate over to the left side of the graph, where it starts up really high, the more fuel we're consuming per kilowatt hour that's generated. Okay, so that means that it's not until the generator is more than 50% loaded that it starts to approach its optimum efficiency range. So for most of us, we're operating the generators most of the time under these low load conditions on the left side of the chart. And so on average, boat owners are paying between $3 and $9 per kilowatt hour generated under these low load conditions. These are crazy numbers. Most of you are probably paying between like 13 and 16 cents per kilowatt hour back home. And I got these numbers from Nigel Calder, and some of you might be familiar with Nigel's writing. He's written a lot of books about marine systems. And I thought these numbers were so crazy that I actually pushed Nigel on the accuracy of these figures. And he reminded me that it's the amortization cost of the generator combined with these low average loads, which drives the kilowatt hour cost through the roof. So this existing generator-based power system design is so backwards that there's several things in the industry we're doing that just really don't make sense. For example, I know boaters, and you probably know boaters, that when they go and start their generator, they go and turn on everything in the boat. They run the air conditioning, they run the water maker, they cook in the galley. Maybe it's a good time to blow dry your hair or make coffee or whatever. That's just what they're doing. And this generator system approach, it teaches us to use more power than we need. I mean, imagine if you did that in your home. You flicked on the light to the living room, and then you proceeded to go around and turn on everything in the house. You started making toast and went to blow dry your hair, and you did all these things. I mean, that's not how electrical power is supposed to work, right? This isn't just not the way the world is going. And it gets even crazier. On bigger yachts, we have these things that are called load banks that heat up the seawater just to discharge it overboard. That's what's pictured here as a load bank. And they do that just to keep the generators happy when they don't have enough other electrical loads to keep it loaded. I think if you have friends outside of boating that saw this, they'd be like, what are you guys doing? So you're catching the hint that I'm not a big fan of generators, and this is the age of electrification, right? And so a lot of folks are interested in switching to lithium batteries, and they know that this technology has really improved. And the battery is a part of the equation, but that's not the only piece. And I'm not here just to talk about the battery. What I want to show you is that our specialty at BoatRX is helping reduce boaters' reliance on these onboard generators. And to do that, we need to adjust our thinking about all three sides of the power equation. So first and foremost, if we want to run our house loads from battery power, including air conditioning, we need to start thinking about increasing the efficiency of our onboard systems. And this is most important with the biggest consumer of power, the air conditioning. Next, we need to make sure that the battery bank has been carefully selected to meet the required run times. And we'll get back to this part later, but batteries are expensive. We want to put the right amount of battery in the boat. Third, we want to make sure we have a way to quickly charge these batteries when we're away from the dock, because it's one thing to take power out of the battery, but we need to be able to put it back in quickly. And so, since number one is we need efficient systems to balance the equation, I want to introduce you to VRV air conditioning, which you might have heard about, maybe you haven't, but it's this new way of thinking about air conditioning on boats that's a little bit different than the way we've done it in the past. A lot of you might be familiar with self-contained air conditioning units. They look something like this. And these have had some advancements in technology, but what I really want to talk about is the marine application for this VRV, also known as VRF air conditioning, which became really popular in the last couple of decades in residential and commercial applications. And that's what's pictured here, these Mitsubishi units. You might be familiar with the terms ductless air conditioning or inverter mini splits. This type of air conditioning is VRF or VRV systems. And so when we talk about VRV air conditioning for boats, we're talking about the same kind of technology. It's just developed for a different application. And so I'm going to get a little bit technical here, so try and stay with me. But this is an example, kind of a basic system schematic of a VRV air conditioning system. And VRV stands for variable refrigerant volume. And when we talk about refrigerant, you might have heard it called Freon before. We're talking about a special chemical that is specially designed to exist in different states of matter, liquid and gas. And when we shift that refrigerant between different states of matter, we're able to absorb heat or release heat where we want it and move heat around the system. So if you look at this diagram, the refrigerant in the system starts its journey in the compressor, which squashes it down to make it a really high pressure, really hot gas. And that refrigerant then travels to the condenser, and that's where it interfaces with seawater in the heat exchanger, and the seawater takes the heat away from the high pressure, high temperature gas and actually condenses it down into a high pressure liquid. And that liquid refrigerant then travels out the orange liquid line where it's distributed to each of these air handlers. And when it gets to the air handler, it reaches what's called an electronic expansion valve, an EEV, which regulates the flow of that high pressure liquid refrigerant into the copper evaporator coil. And that EEV is responding to software that's telling it just how much to open and how much refrigerant to feed into the coil. Therefore, maintaining the temperature of the coil at usually a temperature just above freezing. So it doesn't freeze, but it maximizes the dehumidification effect. Then a strong blower fan blows air over the cold coil and blows it out into your cabin in your cooling zone. And that's essentially how air conditioning works. The vaporized refrigerant then travels back down the blue suction line and returns to the compressor, and it goes around the cycle again. The thing that's really special to point out here is that all of these components are connected to a common controls network, and it's software that's processing the data from a number of temperature and pressure transducers throughout the system to make changes to the compressor speed, fan speed, and expansion valve positions in real time to maximize both the comfort and the efficiency of the system. And that was a lot of information, but I think the best way to think about this is that over the last few decades, we've had these self-contained units that have been around for a long time, and they haven't changed all that much. And when you look at a VRV system, it really works on the same principles as those self-contained units, but it's more sophisticated, and what it does is it extracts more efficiency out of the way everything operates. And I think about it in the same way that, like, you look at cars and automobiles over the last few decades, we're still like, they still have a gas engine, they're still doing the same thing, but we've really increased the fuel economy of these cars over the years to make them more efficient. And that's kind of what's happening with VRV. The other thing to point out is that because it adapts so well to these different environmental changes, if you have a system that's operating in New England in 70 degrees seawater, and then you take that same system down to Fort Lauderdale, and it's operating in close to 100 degrees seawater, like we saw this year, the old style systems that have been around forever don't do anything different. They just operate more inefficiently when they get into warmer water. Whereas a VRV system is constantly adapting to these different changes. And if it encounters warmer water, it's going to run the compressor faster, and it's going to create a higher head pressure of the refrigerant to maintain the temperature differential between the seawater and the hot refrigerant. Now, that's a lot. Some of you might have followed that. But there's a lot that's going on here, and these are sophisticated systems, and I want to try to do my best to articulate how this efficiency is gained. And these systems are at least 50% more efficient than the air conditioners of the past. So we start there. Step one of the equation is get your air conditioning to use less power. So that way we can go on to step two, which is calculating our battery size. Now, the first thing we do is do an energy audit of the boat to get an understanding of how much power the boat will use. And we do that also based on an estimation of how much air conditioning power it will use. And after we do that, we come here and we create this table with 3 different load scenarios on it. That's what you see in the middle there. And the first one is, okay, how long will our batteries provide power for under fully loaded conditions in the daytime sun? And for this particular application, it shows 11.7 hours. Scenario 2, how long can we provide electricity for the boat if we turn the air conditioning off? Well, here it's 73 hours. And then the third one in the yellow there is actually what I find to be the most important figure when we're doing the engineering for these projects, which is when the boat owner goes into an energy conservation mode overnight, meaning that they're just air conditioning their sleeping cabins, how long can the air conditioning system run for? And our goal most of the time is to do overnight, or about 12 hours. And so here's the part that's really important about properly sizing the battery bank. Lithium batteries are expensive. And if you put too big a battery bank in, there's a chance that you might not use all of it. In fact, we've run into this with clients who have wanted big battery banks. They've made the investment, and then I see their usage, and they're actually not discharging much below 50 or 40% on a regular basis. Well, that leaves, lithium batteries, you can use almost all of it. That leaves 20 or 30% of their investment going underutilized. So that's why we don't want to oversize the battery bank. If you undersize the battery bank, well, you've still made a big investment in these expensive lithium batteries, but it hasn't dramatically changed your lifestyle because maybe you can't achieve that goal of overnight air conditioning. And so you still got to start the main engine or the generator. And so my take on this whole thing is helping our clients to really understand that if you're going to make an investment in these batteries, you got to get the sizing right so you get the most bang for your buck. And then the last piece here, part 3 of our equation, is factoring in the recharge times. And there's a few different ways to recharge your battery bank. The first way is to provide rapid charging via an onboard generator. And I know I talked about how I don't like generators, but this is one situation where it makes sense. Because if we run the generator just to charge the batteries, we can maximize its output anytime it's running to make sure that the generator never goes underloaded. And that means that every time the generator is running, if you look at the same chart we showed before, we're no longer operating on the left side of that curve, we're operating on the right side of the curve where it's operating under optimum load conditions. And so the goal here with a hybrid generator setup, where the generator is used for battery charging, is, if it's properly designed and balanced, usually what I try to do is design a system that can provide air conditioning and all the other power for the boat for 24 hours from batteries with only 4 hours a day of generator runtime. So this is an awesome solution. Generators can still be put to good use on these boats. And if you do it this way, not only is the comfort improved, less generator runtime, less fumes, less noise, and all those things, but also you're extracting more value out of your investment in your generator because every time it's running, you're getting the most out of it. The second way to rapidly charge battery systems is to use specialty high output alternators on the main engine. And so these are typically generator-free systems. There's no generator at all. And pictured on the screen is the integral system. There are lots of options these days for high output alternators. And this is the part where I want to highlight the importance of 48 volt DC systems. Most of us are familiar with 12 volt or 24 volts that have been in most boats for many decades. But I want to highlight how if you're a techie out there and you've been thinking about maybe making upgrades to your boat, and you probably heard the buzz about 48 volt systems. Well, why go 48 volts? There's a lot of nuanced technical details about why to do that, but simply the reality is that if the battery bank serves as our buffer between the power that's coming into it and the power that's going out of it, we can only put power back into it at a certain rate if we do it at a lower voltage. And so if that battery bank, if you imagine that it's like a bucket of water, if we try to fill that bucket of water with 12 volts, we're doing it with just a little garden hose. And if we do it at 48 volts, we're doing it with a fire hose. When we're designing these large, high-powered systems, the simple reality is that when we take a lot of power out of that battery bank, we can't charge it fast enough at 12 volts. Even with the thickest cables and all the different things that are available, we can't charge it fast enough. We need to do it at a higher voltage. And as the requirements of boaters are changing, the technology needs to adapt. And so some folks are a little still uncomfortable with the idea of 48 volts or added complexity in their systems, but I'm kind of here to tell you that it's coming. And this is the way to get what we want in terms of our systems. And if you think 48 volts is scary or anything like that, just keep in mind that if you drive an electric vehicle like a Tesla or something like that, you're actually charging at 400 volts. So in the boating world, we're still keeping it tame. So for the last few years, I've been with our company advocating for this all battery, no generator model for air conditioning. And recently we had this customer, Jeff, and he came to us and said, hey, I'm working with David Walters Yachts and Italia Yachts to bring the first 1498 model to the USA. And he said, I don't like the air conditioning option that's available from the manufacturer. And so, and I don't want to have a generator aboard. So what can you guys do? So Jeff came to the right place, and we just applied our 3-part power equation and thinking to any BoatRX system. We applied that to Jeff's boat. And so that includes super efficient VRV air conditioning. You can see at the very bottom left, it's small on this screen, but that's the VRV8 air conditioning compressor. You can see how we squeezed it into Jeff's little system space there, which exists under the cockpit of his sailboat. And then step 2, a properly sized battery bank. These Victron batteries this is an example of how much battery power was required to run Jeff's air conditioning in this 50-foot sailboat overnight. And we didn't undersize and we didn't oversize his battery bank. And we especially didn't oversize because Jeff's a racer and he didn't want to take on more weight than he needed. So this was just right. And step 3, rapid charging. In Jeff's case, we designed the system to have dual high output alternators on the main engine. So this 50-foot sailing yacht has no generator aboard. And we did this installation earlier, I guess, in the early spring. And I hadn't heard from Jeff for a while. And so before this webinar, I wanted to reach out to ask permission to use his name and his photo and everything. And this was the response that I got. So thank you, Jeff. We really value you as a customer, and it's a really big pleasure working on your new boat. And I want to point out that to this day, I think most people still believe that having an air-conditioned boat means having to run a generator 24/7. And we used to think it was impossible to do it any other way. But this is our specialty at BoatRX. We're really good at optimizing for these conflicting demands, as I like to say. You know, you want to have air conditioning, but you don't want to run a generator, or you don't want to spend a certain amount of money, or, you know, trying to figure out all the push and pulls of these systems and getting it all in balance and solving that equation. That's what we're really good at. It's kind of similar to the electric vehicle industry, where a lot of these manufacturers are trying to hit the right price point, but they're also trying to extend their range. And so that's what we're good at. And at the moment, we're really growing. I mean, Erik mentioned a bunch of the manufacturers that we're working with and how we're packaging our systems to be installed in these new production boats that are arriving to the States. That's really been our specialty as we grow as a company. Yeah, I look forward to doing more of it. And thanks everybody for taking the time to hear me rant about something that I'm passionate about. And if you got any questions, I'm happy to do my best to answer them. So Erik, I'll let you jump back in and take over.
Yeah, thank you, Phil. Fantastic presentation. It was, you know, for the amount of technical data that's involved with this sort of side of the marine industry, you know, especially with, you know, electricity, with ohms and volts and everything else going around. It was easy to understand. It was great. It was definitely very beneficial to hear. And, you know, I know we've got a few questions out of some people. I think, you know, we'll start at the top here. So Patrick, he asked, you know, he's planning on converting to lithium ion phosphate batteries. He wanted to see what the process was of converting. What's your take on that?
Well, I guess it depends what if he's asking about whether he's doing it himself or if he's looking to, you know, hire professionals to do it. I of course, you know, advocate for hiring professionals. And the first step in any power system upgrade is to do an energy audit of your boat and understand how much power you require. And that, you know, you got to add up all the appliances, look at their wattage ratings, get an idea of how much power you use on a daily basis. And then maybe create that 3 scenario approach. You go, here's how much power I use when I'm using the boat in its full, you know, full operating mode, and I've got guests aboard or whatever, whether that's with air conditioning or without, and how much power do I use overnight? And with those numbers, that's going to inform the rest of your decision making about how big does your battery bank size need to be, and how long are you willing to run your engine with your alternator or your generator, or how much solar do you need? What's the final figure in that equation to understand how fast you want to charge it?
Fantastic. Thanks, Phil. Another question here, Fred asked, and this is a good question, and I know the answer to it, but I'll let you answer it because you're the expert here on this. So how are the engine makers reacting to customers using these high output alternators on their engines?
Yeah, well, you know, Jeff Kennedy's boat, I was nervous about that, to be quite honest, because we did the dual alternator setup. it was checked out by Volvo mechanics after we completed the job for warranty, and they didn't have any concerns with that. The secondary bracket that we used for the alternator was a part from Volvo, and so we do our best. But I'm certainly not in control of what the engine manufacturer has to say. I can tell you that we also do a lot of work on outboard power boats. And I've had tons of ideas about ways to really juice the output of these like Mercury outboards, for instance. But that's an area where we haven't done it because we know that the engine manufacturer is very particular about not making aftermarket changes. So I can't speak to every engine manufacturer. And Erik, you said you know the answer to this question, so I definitely want to get your take. But there is definitely some level of what your risk tolerance is in terms of upgrading your boat and how important these warranties are to you.
Sure. I think kind of a big part of it is something we dealt with a little bit was, we're putting these bigger, higher amp alternators on these engines, but they're not just your straight out of the box alternator. They're pretty advanced, especially the control system that goes involved. And, I know, Phil, and I like it too. You've been a proponent of the Wakespeed system. Can you give a quick rundown of that?
Yeah, absolutely. The Wakespeed alternator regulator, it controls how much power your alternator puts out. But I think about it differently. It's actually controlling the amount of power your alternator puts out by regulating it based on a number of other inputs. In particular, the temperature, the internal temperature of the alternator. And if you have it networked, the actual load on the engine, it can talk to your engine to understand what the engine can take. And it takes all that data in and decides how much resistance to put on that pulley. And it does it all in real time. And we can also apply what we call a load curve, meaning that when the engine's at lower RPMs, we can apply a different amount of resistance to the pulleys on the engine than we do when it's at mid or high RPMs. And this we do to try and match the horsepower capability of the engine. And when you do that, the argument is that we're actually making the engine happier and run smoother because diesel engines don't like to be underloaded. And the nature of a fixed blade propeller is that it's sized for the maximum cruising RPM of the engine, meaning that only when you put the throttle down all the way is your engine fully loaded with the maximum resistance. And actually, at any other RPM range below full throttle, the engine has more power to give than you're taking from it. And by applying greater resistance to the engine, it actually becomes happier, becomes more fuel efficient, and believe it or not, has less wear. And it's a kind of I mean, some people have experience with diesel engines. Some people here maybe more than I do, but by reducing like cylinder glazing and carbon buildup in the diesel, you actually can increase the life of the diesel by adding these high output alternators.
Awesome. Thanks, Phil. The next one that came up was from Marshall. What are your thoughts on the DC generator?
So it's really all comes down to your system design. The nature of most generators that output DC power is that they actually still start with AC. If you have a brushless generator or brushless motor, which is what most of these things are, they produce an alternating current power, usually three-phase alternating current. And that current has to be rectified into DC power. So there's always power conversion in one way or another out of these generators, whether you think it's a straight DC generator or not. All that being said, I'm going through this right now with my boat. I'm putting a Whisper Power variable speed generator in, and I'm doing a 48 volt system. And in my personal boat, I had the opportunity to do a 48 volt DC generator to directly feed my batteries. And I really like that opportunity, that option. And I had a really hard time trying to make this decision about what I should do. And because I'm a blue water sailor, I actually ended up going with a generator that outputs 230 volts AC voltage. Because in my mind, if my inverter fails or my 48 volt battery pack fails, I'm actually going to use my generator to still be able to make water, or in my case, still be able to run the electric cooking in my galley. So it's really a design preference. And you got to take in all these other factors. It's not just about whether you should have a DC generator or not.
Awesome. Thanks, Phil. James asked how many air conditioning units were used in Jeff's boat and what was the project cost?
Yeah. The Jeff's boat had what's called the VRV8 compressor, so a single compressor with about a 35,000 BTU air conditioning capacity. And it had 3 air handlers for 3 different zones, the aft cabins, the main salon, and the V berth. And those were 2 12,000 BTU capacity air handlers and a 30,000 BTU in the main cabin. You'll notice that the capacity of the air handlers exceeds the compressor, and that's okay because we can kind of move the air conditioning ability around the boat where it's needed with a VRV system. So the short answer is, I guess, 3 zones for the air conditioning. The project cost, I'd like to tell you. I don't know if I recall exactly. It was between $100,000 and $150,000.
Thanks, Phil.
Yeah.
Howard asked, how would you integrate, or how does the use of solar and wind power generation fit in with your system?
Very easily. And the only reason I don't highlight solar and wind power like in my talk is because that stuff is, unless you have like a massive amount of real estate, like on a big catamaran to mount solar panels on, it's icing on the cake. Solar power is great for, keeping the fridges on when you leave the boat on a mooring and you're not there. But in our world, we're dealing with such high power systems that the amount of power we get from solar is really trumped by the amount of power that we need from other sources. And so what we do when we've taken on these projects is we often work with the client and say, like, hey, if you want to provide solar panels mounted on the boat, which often require like a custom installation, either custom fabricated, metal structures or solar panels that are adhered to parts of the deck or things like that. You want to provide that stuff, we'll integrate it into your system, and it's only a bonus if you can add it.
Mike came up with a nice question here. So, how would you describe the air conditioning system? I would surmise he's commenting on a system like Jeff's in terms of how the components can be installed in limited spaces. How do they connect? The ducting runs, the size of the through hulls, that kind of thing.
Yeah, that's a good question. The system has been designed for refitting, and typically, so the VRV system is most similar to an installation process to traditional split systems where the compressor and the air handlers are separated. And traditionally, we've had to use copper tubing, insulated copper tubing, to connect those for the refrigerant to flow in. But Thermodynamica, the manufacturer of the VRV system, has a proprietary flexible refrigerant hose that we use in a hydraulic press that puts the ends on, and it's pre-insulated and it comes on these spools. So I want to highlight that first because we've found it relatively easy to be able to make the runs that are required for the refrigerant hose to the different zones. And the air handlers themselves are actually typically smaller than the type of the alternatives that would go in there. And that's because the VRV system is really good at running a colder coil and higher air velocity. And together we can create the same amount of BTU capacity as you would with a lower air velocity and a higher coil temperature. The hardest thing about refitting a VRV system in a boat that didn't have a split system before, didn't have chillers or something like that, is finding a place for the main compressor. So if you don't have a space in the engine room or in a system space, we often have to create one, whether that's under a berth or that's in a, we fiberglass in some knees into the side of the hull and create a systems platform. We usually have to get creative. And the through hulls for the first 3 sizes of the VRV, which applies to most applications, the VRV8, the 12, and the 18, are all 1 inch. So you need a 1 inch in and a 1 inch out, and everything else happens in the boat. So that's usually different than self-contained units. If you have 3 zones of self-contained, you need at least 1 in, sometimes more than 1, and you need an outlet for every one of those units. So we actually have fewer through hulls.
Awesome. And Mike asked that this essentially a very similar question to Howard, about hydro generators being part of that system. I assume it'd be probably the same answers about solar panels. It's a nice add-on,
Yeah, the hybrid, what makes it a hybrid generator is just pairing a generator with proper charging equipment and making it, balancing everything so it all works in harmony. That's what makes it a hybrid generator. So you don't really buy a hybrid generator, you just buy a generator, and then by integrating it together with your battery system, you have a hybrid generator system.
I think it said hybrid. He meant a hydro generator.
Oh, hydro, sorry. Yeah, same idea.
Okay, awesome. Kevin asks, can 48-volt battery be used for thrusters and windlass?
Yeah, I just put a 48-volt windlass on my boat.
Mhm.
And I've got a project coming up where we're well, we're not installing the thruster, but we're connecting a 48-volt thruster on the large yacht to our 48-volt battery system. I can tell you that the windlass companies, the thruster companies, there's only a handful of models out there so far that are 48 volts, but they're very happy to see this transition to 48 volts as well, because all of their systems run cooler, they can be more powerful. Everything's kind of better at 48 volts. So I think you're going to continue to see more and more, especially, I'm not saying all things all on their boat are going to go 48 volts, not at all, but the high power things like thrusters and windlasses for sure. And the real benefit, especially in my case, is that it eliminates the battery bank, the battery pack that sits in the bow. You don't need that anymore because the high voltage cabling can just go back to the main batteries.
That's a great point. It'll save some weight and some extra stuff on the boat not needed, more space available. Mm-hmm. Mike asks, do you ever see air-to-air marine HX units becoming an option to avoid pumping seawater through the boat?
This has been done. Dometic used to make one that was like it looked like an RV unit that went on a pilot house of like a commercial boat. I think that's like if you got like maybe a steel barge or something like that, you don't want to have to put all this plumbing into. They made these things. They've discontinued that. And the primary reason is because the aluminum finned condenser coils that exchange heat with the air, they just rot out in the salt environment. And we've seen this not just in marine, but in a lot of coastal homes. They have the same problem. And I have done a little bit of shoreside HVAC work in my time in St. Thomas, and we saw this all the time. So could be done, but it's not. It's the equipment has a super short lifespan on the water.
Makes sense. And then we got, I think it's the last one we got here. Rob asked, so he has self-contained units, including under his bunk where he sleeps, and they're pretty noisy, cycling on and off. Is your system quieter?
Yes. Oh my goodness. I have the noisiest air conditioner on my boat right now. It drives me nuts, and I don't have my VRV system yet. I'm really excited to put it in, but that's the thing I'm most looking forward to, because you can put the compressor in a more sound isolated space. And then the air handler itself is only the sound of the moving air. And if you do really good, proper ductwork installation, then the less you disrupt the airflow, the quieter the airflow is. But the fan speeds as well are really variable. They have like thousands of steps between 0 and 100. And so if you go to sleep and the boat's been cooled down, the fan can slow down. These air handlers actually have a night mode, they're called, because they're used in super yachts where some of those clients demand that it's imperceptible, the air conditioning. And so it's possible to actually make it nearly silent.
Excellent. Well, Phil, thank you very much for joining us here this evening. I know we tried to get this together for a while, and I'm glad we could bring everyone in and show you guys, what's the capabilities out there for marine air conditioning and improving your comfort on your boats. And like I said, I'm Erik Haaland at David Walters Yachts. I'm based out of Annapolis and Fort Lauderdale, so you know where to find me. Phil is here out of Annapolis at the moment, but the company's still headquartered out of Boston with your partner, Betsy. Mm-hmm.
That's right. Yeah, we're primarily a New England-based company,
Mm-hmm.
and I'm enjoying my time here in Annapolis as we continue to grow.
Fantastic. Well, if you guys didn't catch the whole video, we'll be posting it on YouTube as well in the next couple of days, so it'll be there forever. But great time. Thanks, everyone, and we will see you at the boat shows here in a few weeks.
Thanks, everybody. Thank you, Erik.
All right. Take care.
Bye-bye.
Bye.